My name is Michael Tawonga Kamanga. I'm here to take you through chemistry, that is chemistry from 1, and we are going to look at the physical and chemical changes. Physical and chemical changes. So chemistry from 1, physical and chemical changes. Now in this lesson, um, we'll look at how to write the chemical formulas of compounds, elements, molecules, substances in general. So we'll look at how we can write the chemical formulas. Remember previously we looked at how do we determine the valency of given elements, radicals. So we saw that valency is determined by using the position of an element in a given group. As for the radicals, we say that the valency corresponds to the charge on a given ion. So if it is 2 minus, then the valence is 2. If it is 3 minus, then the valence is 3. If it is minus, then the valence is 1, and so on and so forth. We also looked at the types of valences. We said valences can be positive, negative, or neutral. Positive, negative, and neutral. So in this lesson, this is our success criteria. By the end of this chapter, you should be able to determine the chemical formula of compounds. You have to determine the chemical formula of compounds. So we'll have a list of compounds and we want to see how do we write the chemical formulas of compounds. Remember, in a chemical equation, mostly we use a chemical equation and not word equation, because in chemical equation, what is needed is the chemical formula of a given reactant or product. So by the end of this lesson, you should be able to determine the chemical formula of compounds. Okay, so let us see, revise on the chemical reactions and chemical changes. Well, we say that chemical reactions are fundamental processes in chemistry where substances known as reactants, they undergo transformation. So there's a transformation by reactants. So reactants undergo alteration or transformation. Of course, it is because of a number of factors. You talk of concentration, you talk of temperature, you talk of light intensity, and so on and so forth. So if they undergo this transition, this leads to the production of a new substance. That new substance is what is known as the product. So understanding chemical reactions is crucial for various scientific fields, which includes chemistry, biology, environmental science, and engineering. So this is very, very important. This is crucial. Well, therefore, a chemical reaction involves the breaking of chemical bonds in reactant molecules and the formation of new bonds to produce products. This process results in a change in the chemical composition of the substances involved. So this process results in a change in the chemical composition of the substances involved. So the same chemical reaction and the chemical changes, these two, they are closely related concepts. They are very close because without a chemical change, there is no chemical reaction. Without a chemical reaction, there is no chemical change. Because chemical changes, remember, when compared with physical changes, the chemical changes, they always produce a new substance, unlike the physical change. So a chemical reaction is just a process in which substances do undergo a transformation to form new substances. And this transformation, however, it involves the breaking and forming of chemical bonds, chemical reactions that simply characterized by the following. So you will know that a chemical change has taken place if you observe the following. There is energy change, color, temperature, and the formation of new substances with different properties. So these are the indicators, which show that indeed there is a chemical change. So this chemical change overall, it just refers to the composition of a substance where the substance changes its composition, it undergoes transformation, and by the end of the day, there is a production of a different substance. So chemical changes are a direct result of chemical reactions. Example, yes, previously we looked at the very same example where we said iron uh, undergoes rusting, and again, when you are baking, you mix different ingredients, and these ingredients undergo transformation to produce a final product, which is a cake. So indeed, those are um, examples of a chemical change or a chemical reaction. Now, in a chemical reaction, remember we said a chemical reaction is presented, or it is represented by a chemical equation. A chemical equation, it has reactants, it has products. Now, in a chemical equation, we normally use chemical formulas for substances. So a chemical formula is just a way to represent a chemical substance using symbols and numbers. It provides information about the types and quantities of atoms present in a molecule or compound. So, chemical formulas represent the composition of compounds. They indicate the types and numbers of atoms present in a molecule. So, what is the breakdown of this chemical formula? Well, the chemical formula has element symbols. These are the symbols from the periodic table that represent different elements. For example, H stands for hydrogen, O stands for oxygen, and Na stands for sodium. So yes, a chemical formula, it has element symbols. Then here it's supposed to be 2 and not 1. Chemical formula, it has subscripts, and these are numbers which indicate the number of atoms of each element in the molecule. So the subscripts that are there to tell you the exact number of atoms present in the molecule. For instance, in order, the subscript 2 after H means there are 2 hydrogen atoms, and the absence of a subscript after O means there's only 1 oxygen atom. So I think you can see here, H, remember we said H stands for hydrogen, O stands for oxygen. So H2, this is the subscript. This subscript is telling you that yes, we have hydrogen atom in order, and the hydrogen atoms, there are 2. No wonder there's this number 2. Here, as you can see, there's no subscript. In other words, for this oxygen, there is 1, because 1 is always silent. Like in mathematics, do you write 1x? No, you just write x in algebra. So here, there is silent 1. So for oxygen, we have 1 atom. Then we have parentheses and blankets. So these are used in more complex formulas to group atoms or ions. For example, in calcium nitrate. Calcium nitrate. The parentheses indicate that the nitrate ion, which is NO3, is present in a quantity of 2. The quantity of 2. That is why you have these parentheses. So this is telling you that everything which is inside, if you want to know how many nitrogen atoms do you have, you say 2 times, here there's 1. Then for oxygen, it will be 2 times 3, which is 6. So everything which is inside, it has, it shows that the 2 is representing everything which is inside here, and not calcium. Please take note, because calcium is not inside here. Then we also have charges. We have charges. So for ionic compounds, the formula might include charges to indicate the ionic nature. For instance, you have Na superscript positive and Cl superscript negative. These are the charges, meaning to say that sodium, it has a positive charge, and the chlorine, it has a negative charge. And when we start looking at ions, this no longer, you cannot call this is no longer chlorine, but it is a chloride ion, and this is sodium ion. So it shows the charges of sodium and chloride ions respectively, the charges, these charges. For example, let us look at more and more examples. Water. This formula shows that each water molecule consists of 2 hydrogen atoms and 1 oxygen atom. Good. As you can see here, we have 2 for hydrogen. Like I've already said, here there's a silent 1. So that is oxygen. So this is water. Carbon dioxide, CO2. This formula indicates that each carbon dioxide molecule has 1 carbon atom and 2 oxygen atoms. For sodium chloride, NaCl, this formula signifies that sodium chloride is composed of 1 sodium atom and 1 chlorine atom. Chemical formulas can be simple sometimes or complex, depending on the substance they represent. So always, for the chemical formulas, they will depend on the substance they are representing. So we don't want to be using words here. Let's say water, but we should be using the chemical formula H2O. So this is a good language for chemists. Carbon dioxide, CO2. Sodium chloride, NaCl. Now, we can determine the chemical formula of a compound using valences. So the issue to do with valence is very, very important, because it is the valence which will always assist you in writing the chemical formulas. So using valences involves understanding how atoms combine based on their ability to form bonds. Valence or valence is just the measure of an atom's ability to bond with other atoms. the measure of an atom's ability to bond with other atoms. That is the valence. How do we identify the elements involved? So you know the elements, you determine which elements are present in the compound. Here now, we want to write the chemical formula. So first of all, you have to know the elements. You determine which elements are present in the compound. For example, in a compound of iron and sulfur, the elements are iron, which is Fe, and sulfur, which is S. So you have to know the elements. The elements are in iron is Fe, and in sulfur it is capital letter S. Now, on the same, you have to consult the periodic table if you want to know the valences of elements. Remember, you have to go and consult the periodic table. You find the valence of each element. First of all, you know the elements, then you have to know the valence of each element. As simple as that. Know the elements, then know the valences of these elements by referring to the periodic table. So common valences are often listed in the periodic table or can be deduced from the element's position. Group 1 elements, group 2 elements, group 3 elements, group 5 elements. For group 1, for example, sodium, the valence is 1. Group 2, magnesium, the valence is 2. Meaning to say that all elements in group 1, they have one valence, a valence of 1. Group 2, a valence of 2. Group 3, a valence of 3. Group 5, of course, group 4 here, it was skipped. It is supposed to be either way. 4, remember, valence can be positive or negative, right? No wonder it was skipped here. So it is 4, whether positive or negative. Then group 5 elements, a valence of 3 or 5, meaning that either it can lose 3, is it? No, it can gain 3 or lose 5. Group 6, the valence is 2. Group 7, the valence is 1. What about group 8? Group number 8, what is the valence? Can you share what is the valence in the comment section? Yes, the valence is indeed 0 because it can neither, the elements neither lose nor gain. Then you use common oxidation states. Some elements have multiple valences. For example, iron can have valences of 2 and 3. Some, not all of them, some have more than one valence. So we have iron, for example, there's iron 2 and iron 3. Then you are supposed to determine the combining ratios. You cross multiply the valences. The valences, you have to cross multiply them. So to achieve electrical neutrality, that is the compound is electrically neutral, balance the valences. How do you balance the valences? The least common multiple of the valences will help determine the ratio of atoms. So there you say the compound is electrically neutral. It is electrically neutral. So you balance the charges. For example, our first example is iron and sulfur. Iron has a valence of 2 or 3. Remember, some elements have more than one valence. Sulfur has a valence of 2. So sulfur has only one valence. But for iron, you can have iron 1, another iron 2, and iron 3. So here, be very, very attentive, because we want to determine the combining ratios by cross multiplying. Why are we cross multiplying the valences? Why are we cross multiplying the valences? Yes, we want to make sure that the compound is electrically neutral. And remember, it was also mentioned previously that the valence can either be positive or negative or neutral. Here for iron it is positive, for sulfur it is negative. A quick explanation to that is that the iron it is a metal, while sulfur it is a non-metal. So iron it is a metal, and the metals have a tendency of losing electrons. So if they lose electrons, they gain a positive charge. While non-metals, they have a tendency of gaining electrons. So if it gains an electron, it becomes negatively charged. So that is a quick explanation. But there's more to that. And you will know the reasons as we continue with other lessons. Okay, now combination. Combination. Remember, we have to combine. For iron, we are using F, the one which is having the valence of 2. For sulfur, we are using the one which is having a valence of, no, rather, for sulfur we use 2 because remember it has one valence. So the valence ratio, as you can see there, is 1 to 1. It is 1 to 1. It is 1 to 1 because the simplest ratio there, it is 1 to 1. So the formula is FeS. Here, what was done is 2 cross multiplied here, then 2 for iron cross multiplied here. So if you interchange the charges, there will be 2 down here as a subscript, and there will be 2 down here as a subscript as well. So yes, we have to simplify. So the common factor there is 2. If you 2 divide into 2, then there will be 1 1. So you may tend to wonder here that where is 1 to 1 coming from? It's because of the 2 2. It has a common factor. If you divide 2 into 2, 1. 2 into 2, 1. That is why there's a ratio of 1 to 1. So the simplest formula of iron and sulfur, which is iron sulfide, is FeS. This is the empirical formula. There's empirical formula, then there's molecular formula. Example 2, we have magnesium and chlorine. So magnesium Mg has a valence of 2. Chlorine, it has a valence of 1. If you want to balance the charges, what do? You need 2 chlorine atoms for each magnesium atom. Thus, the formula is magnesium 1, chlorine 2. In simple terms, if you cross multiply, you interchange the charges. Once the charge becomes a subscript for chlorine, it will no longer have the sign positive. While for chlorine, it will go as a subscript for magnesium. So it will not be minus, it will just be 1. So 1 is always silent. No wonder here there's MgCl2. So you have to interchange the charges. You have to interchange the valences. For iron sulfide, 2 2. If we simplify further, then there was 1 to 1. Here, for magnesium chloride, magnesium has a valence of 2, which will be interchanged with the chlorine, which has a valence of 1. So if you interchange them, then magnesium will have 1 as a subscript, then 2 for chlorine as the subscript. So you write the chemical formula, you use the ratios, you combine the elements in the simplest ratio that balances the total positive and negative charges. So it's just a matter of balancing the charges. Because if you have one magnesium which has a charge of 2 and one chlorine which has a charge of 1, it simply means that to balance the charges, for you to have 2 chloride ions, you need to have a 2 here. Here, to balance, here it's supposed to be 2, here 2 as well. So here you multiply by 1, here you multiply by 2. That's why there's a 2 here for chlorine and 1 for magnesium. So you write the chemical formula using the ratios. This is very, very important. Then you have to format the formula. Write the chemical symbols with appropriate subscripts to indicate the number of each type of atom. So calcium and oxygen. Valences for calcium, it has a valence of 2. For oxygen, it has a valence of 2. So again, you see there the ratio is 1 to 1. If you have 2 calcium, you need 2 oxygen. If you have 1 calcium, you need 1 calcium. If you have 3 calcium, you need 4 oxygen. I mean rather 3 oxygen. So let us go for the simplest ratio, which is 1 to 1. So that's the formula here is calcium oxide, CaO. Here we're just writing and we're not naming. Naming will come in the other lessons. Aluminium and oxygen. Aluminium, it has a valence of 3, and oxygen, it has a valence of 2. So for every, if you want to balance the charges here, for every 3 aluminium, yes. So to balance the charges, you just interchange. If you interchange for 3 becomes a subscript for oxygen, while 2 becomes the subscript for aluminium. So you are just interchanging the charges. As you can see here, for aluminium oxide, you need 2 aluminium atoms for every 3 oxygen atoms. Thus, the formula is Al2O3. Because we want the charges to balance. They should cancel each other and they should be electrically neutral. Well, in summary, when you want to write a chemical formula, you have to identify elements, you have to find valences, then you have to balance the charges. Then you have to write the formula. So if you do these 4 things, you have a perfect chemical formula. And chemical formulas, yes, they can be simple or complex. But if you master these steps, you can always be writing correct and complete chemical formulas, which is very, very important. So issues to do with chemical formulas, they are helpful. They are really helpful. You use valences, or using valences is just a fundamental approach to understanding how atoms bond and form compounds. This method ensures that the resulting compound is stable and electrically neutral. So yes, chemical reactions, chemical changes. These are summarized in a chemical equation. Chemical equations, we have reactants and products. These are represented by chemical formulas. So writing chemical formulas involves identifying the elements, involves finding valences, it involves balancing charges, and then you write the overall chemical formula. Well, having gone through the process of writing chemical formulas, there is an activity here, and please feel free to provide answers in the comment section, and you can as well compare your answers with my suggested answers. My suggested answers, they are not 100% like perfect. You know what I mean? You can research for more and add more and more content. You are always welcome. So please feel free to give your answers in the comment section. Number 1, write the chemical formula for a compound formed between potassium and sulfur. Determine the chemical formula of a compound formed between calcium and chlorine. What is the chemical formula of a compound composed of aluminium and bromine? Write the formula for a compound made of magnesium and nitrogen. If you have any questions, please feel free to contact us on our WhatsApp number, and you can also visit help@xulendo.org. You visit Xulendo online, then is xulendo.org. For today's lesson, the following are the references: Excel and Succeed Junior Chemistry Book 1, Achievers in Chemistry Book 1, Jungle Chemistry Book 1, Samuel Karea Chemistry Book 1. Illustrations, design, and graphics. These were done by Charlotte Donning and Dave Mumba on Works Xulendo. For the photos, this is the link for the photo which I've used. Well, until we meet in the next lesson. Bye-bye.